Hi! In my previous video, I attempted to confirm the grades of my largest magnets using a kitchen scale, and failed at it. I did find a use for a scale with magnets, but couldn't determine the grade. This time I will go back to a method I have had some success with earlier for smaller magnets. Will the method work for extremely large magnets too, or will their grade remain a mystery? Be careful with large neodymium magnets. Don't let them bite ya. The grade of a magnet is always interesting since it tells you how strong the magnetic material used for the magnet is. The higher the grade, the more concentrated the magnetic field is, giving a stronger magnet. Grade N52 is the highest commercially available, but tricky and very expensive to achieve with larger magnets. My largest magnets are therefore not grade N52, but N45, which is still ridiculously strong, especially in these extreme sizes. But are they in fact grade N45, and will the method I use for smaller magnets work for huge magnets? The method is to measure the magnetic flux density at the center of the pole and compare it to calculated theoretical values for the grade ranges. Let's get straight to it and stress test the method using my largest magnet, the 150 by 100 mm monster. First, I find the center of the circular pole using the chord method from the earlier video. Since this magnet is made up of two magnets, I'll measure on both poles. I will also use both of my Gauss meters. The F71 is by far the most precise and measures in 3D. In the way I am holding the probe, it is the Z-axis reading that counts. But because I am a human and hand-holding it, I will make a second measurement with my other Gauss meter. If the measurements are close, they are more likely to be the right ones. Now, that's what I call a near-perfect result. All measurements are very close, despite the magnet being made up of two magnets, and using two different Gauss meters. The question is, what grade will the calculation say this reading represents? After calculating the expected Gauss values in the spreadsheet from Supermagnetis website, link in the description, I get this grade range. The measured magnets are sold as N45, so we should expect the readings to be in this area. Let's plot in the readings from the Gauss meters. Grade N38? That can't be right. I can think of three explanations. Either I messed up the readings and calculations badly, the magnets ain't grade N45, or this calculation method simply doesn't work for magnets of extreme nature. I've got another extremely sized magnet we can stress test the method on, a very wide 200 by 50 mm, also advertised as grade N45. Same drill as before. This magnet has an oddity compared to the first one. In the spots right on the center of the poles, the North Pole is 3.5% stronger than the South Pole. As a whole, the two poles should be equally strong on a magnet, but at the center spots on this magnet, there's a small difference. A bit weird that the magnet made up of two magnets is more consistent between poles than this single magnet. Maybe magnets aren't as predictable as the pole axis method implies. Anyway, here is the result for the 200 by 50. Hold on, I think the animation froze. No, that's it. That's the result. N30 to N33. No way the manufacturer got the grade this wrong. I suspect this method doesn't work for huge magnets. I looked into the original paper that the calculations in the spreadsheet are based on, link in the description. The authors tested the calculations on a 3 by ½ inch cylinder magnet, 27 to 30 times smaller than the 200 by 50 and 150 by 100. We are in uncharted territory. Since I have an extensive magnet collection in grade N45, I may as well try to explore it. Here's a quick summary of hours of work. The method worked well for the 70 by 20 mm magnets I tested in an earlier video. Perhaps not surprising because they are close in size to the cylinder magnet in the original study. I tried going a bit wider to an 80 by 20. It also has different center strengths, but at least one of the poles ended up being better than spec'd. Looks like Grade N45 is realistic, though I may have ruined the North Pole center on this magnet at some point. Going just a centimeter wider to 90 by 20, it all collapses. The center spot readings are again acting up, and I see no correlation between the calculations and advertised grade. The result is like a combination of the results from the biggest magnets that indicate N30 and N38. Seems too wrong to be true. On a thicker 90 by 30, it's a little better, but it still seems like 90mm is too wide to predict for the calculations. Going wider again to 100 by 30 is even worse. For an easy overview, I tried plotting all results at once, ranked from narrowest at bottom to widest at top. It's a bit messy, isn't it? However, I do see a trend. The wider and more elongated the magnet, the more inaccurate the grade calculation seems to be. I'm still not sure of the grade of my biggest magnets. There is a more advanced option for estimating grades that I haven't tried before. After a short message, I will give it a try. Hang on. A big thanks to all my patrons. I appreciate your help with keeping these videos like this one coming. For just $1 a month, you can help me out too and get full access to all my posts on patreon.com. Link in the description. Thank you. For more advanced calculations, I will use a free program called FEM. The 200 by 50mm magnet was way off using the simple spreadsheet calculations, so here I have modeled it in the program. Actually half of the magnet, since that's how the program works in axisymmetrical mode. This is my very first model in this program. Hope I didn't mess it up. Let me calculate the magnetic field values for the magnet as a grade N45 and zoom in. Now I find the value for the sensor location right over the center of the pole. The program tells me I should see 2900 Gauss. Well, that does fit well into the N45 range from the simpler calculations, but I only measured around 2400 Gauss. Switching to grade N33 in FEM, I got around 2400 Gauss. Great! Now I've got two calculations telling me my N45 magnet is only N33. Though only at the center of the pole. The beauty of FEM is that it calculates at all spots. I can make a second measurement on the center of the side of the magnet, right around here. Actually, the sensor will be 2mm outside the edge, so more like here. The value at this spot should be around 3800 Gauss for an N33 magnet of this size. Time to measure in real life. Will it be 3800 Gauss? No, it is way more. 4820 Gauss. 1000 Gauss more than calculated. Maybe the magnet is an N45 after all. Back to FEM, changing to grade N45 and the sensor point on the side's center. No, grade N45 is still lower than the 4800 Gauss I measured. I have to switch to grade N50 to match the real-life measurement. N50. Suddenly, grade N45 seems more right for the 200 by 50mm magnet. If you are an expert at using FEM, I would like to have my values confirmed in a comment. I will experiment more with this program, but for now, it looks like the large magnets break the limits of what is possible to calculate for me. They are probably grade N45, but it's hard to prove. The true grade of my monster magnets remain a mystery. Hope you liked this video enough to click like and subscribe for more like it. Thanks for watching. Bye for now.